Okay, so this time we've got this integral. It looks more complicated with the root on the bottom there being 9 minus 4x squared. Okay, well, first of all, let's just appreciate we do have x squared there. So let's square this, yeah? So that will imply x squared will be all of this squared, right? So put it in a bracket to show that I'm going to square it. And when you square 3 over 2, well, top becomes 9, bottom becomes 4, and sine theta becomes sine squared theta. So that's what's going to go in there for x squared, okay? So we need to replace dx as well. So dx by d theta will be 3 over 2, and sine theta, of course, becomes cos theta. Take then the d theta up, okay? So therefore, dx will be 3 over 2 cos theta d theta, okay? We need to do the limits as well. So let's sort out the limits. So what have we got when x is 0? Okay, so 0 will go in here. So 0 will equal to 3 over 2 sine theta. So 3 over 2 times sine theta is 0, which means then sine theta has got to be 0, okay? And then take the sine over, so sine to the minus 1 of 0 will equal to theta, and of course we know that is 0. Okay, the next one then, when x is 3 over 2, 3 over 2 equals to 3 over 2 sine theta. Okay, so they will sort of cancel, or you can take it over and divide or whatever, you end up having 1 equals sine theta. So we do then take the sine over sine to the minus 1 of 1 equals theta, and that just comes out to be pi by 2, right? If we do that on your calculator. So we get the integral then. So it'll be, our limits will go from 0 to pi by 2, and it'll be 1 over the square root of 9 minus 4. Okay, and remember then, x squared, we figured it out to be that, right? So it'll be times 9 over 4 sine squared theta. Okay, that's what's going on in that root there. So it'll be 4 times what x squared is, okay, which we worked out earlier. Don't forget then to put your 3 over 2 cos theta d theta there. Okay. So let's have a go on the next line. And in fact, what we'll notice here is that the 4's will cancel, which is quite nice, yeah? Okay. So we just left with 9 minus 9 sine squared. Maybe we could put the 3 cos theta on top there this time. So the 3 cos theta on top here. The 2 can go on the bottom, of course, because it's bottom of the fraction there. So put it in front of the root, and you have this. Now, can we start to see similarities? So the last question. Well, of course we can, can't we? Because you've got 9 minus 9 sine squared. Think about what I'm going to do next, okay? It might be obvious now if you really understood the last question. You can see inside that root that we've got a common factor of 9, and we can factorize it. And we get 1 minus sine squared theta. Okay. So in that bracket is 1 minus sine squared, which of course we know is just cos squared. So I'll keep the 9 as it is, but that will become cos squared theta. So then we can root that, can't we? Okay, quite simply we can root that there. So this becomes the integral 0 and pi by 2. So on top we've got 3 cos theta. On the bottom you've got 2. Root this, so that will become 3 cos theta, yeah? Square root of 9 is 3. and square root of cos squared is cos. Okay, and it's lovely because you can see that then the 3 will cancel with that 3, the cos theta will cancel with that cos theta, or you might just see 3 cos theta cancels with that 3 cos theta. What are we left with? Well, you've got 1 on top, 2 down bottom. So what you're actually going to be doing is you're going to be integrating 1 on top, 2 on bottom, so you're going to be integrating a half with respect to theta. And that's really easy, isn't it? Because it's a constant. So then with respect to theta, it'll become a half theta between pi by 2 and 0. Put the limits in, so it'll be a half times pi by 2. Take away a half times 0, so that will be pi by 4. And you multiply them, and there's our answer.